Hey guys, myself Ray, and today we'll be solving the POTD, the problem of the day of LeetCode for 5th September. So the question is a medium level problem and it is minimum operation to make the integer zero. So basically the question says that we have been given two integers, num1 and num2 basically, and it is saying me that in one operation I can choose an integer I in the range of 0 to 60 and subtract 2 to the power I plus num2 from num1. And I have to return the minimum number of operations needed to make num1 equal to 0. And if it is not possible, I have to return minus 1. Okay, so that's quite an interesting question and it's looking like a very much mathematical problem. So if I see the first example here, so in my first example, my num1 is equal to 3 and my num2 is equal to minus of 2. So now they are saying me to do the operations such that if it is possible to make num1 0, then tell me the minimum number of operations this operation I can do so that num1 becomes 0. And if it is not possible, then I will return minus 1. So for example, in this case, what they are doing is like they are saying in the first operation, I will do my num1 is 3, so I would keep it 3, and then I would take my I as 2, and I would do like something like this 3 minus 2 to the power 2, and here it will be minus of nums of 2, and my nums of 2 is minus of 2, so it will be minus of minus of 2. So ultimately, it will be to the 2 square is 4. 4 minus of minus is I think uh, 6. Sorry, it will be plus. So 4 plus minus 2 is minus 2, and it will be ultimately, I think, 1 because 3 minus 2 will be 1, right? And now if I go to the second step will be now my num1 is updated to 1. Now, what I will do is like, I will again do another operation, and here they are choosing I is equal to 2, right? Again, okay. So if I do this thing again, so what will happen? So 2 square is 4. 4 plus minus 2 is minus 2. And 4 plus minus 2 is 2, sorry. 4 plus minus 2 is 2. And 1 minus 2 will be minus 1. And now, again, it is minus 1 here. Now they are saying me to choose I equals to 0. So if I now choose I equals to 0, then what will happen? It will be 2 to the power 0 plus minus 2. And so it will be like 1 plus minus 2, that is minus 1. So minus 1 plus 1 will be 0. And so in three steps, we reach 0. And they are saying that it can be proven that 3 is the minimum number of operation that we need to perform so that when num of 1 becomes 0. Cool. So that was a dry run of a test case. So now if I think about how to solve it. So first of all, what I am thinking is like, why not like represent things mathematically? So if I try to represent things mathematically in this situation, what will happen is like I have my num of 1, and let us consider that we have taken k number of steps now for now. So if I think that if I have taken already k number of steps, so what I need to do is that in k number of steps, so num of 1 minus of. So now what will happen is that in k number of steps, I could have taken a lot of powers of 2. So for example, it can be 2 to the power a plus 2 to the power b, and there can be like dot k times. So I have to take about k powers of 2 here as because I have done the operation k times. And also I will be doing plus of k times num of 2, num2. Because, yeah, I have done the operation k times. So my num2 will be like subtracted from num1 k times. And this must be equal to 0 in order uh, for us to like reach a solution where my answer is 0, where there is an answer or the num1 is 0, right? Okay, so that's the thing. If I do mathematically, so if I rearrange it little bit, so what it happens is like if I keep num1 and num2 at left hand side, so it becomes num1 minus k times num2 is equal to 2 to the power a, or if I just copy it, so yeah, so my equation reduces ultimately to this, right? So that's my reduced equation now. So basically, what I need to do is that for a particular k, I need to prove that hey, this k will satisfy because I can like represent this thing in terms of sum of k powers of 2. So yeah, so if I consider this thing is x, so if I say my x equals to num of 1 minus of k times num2, then I have to just prove that my x can be represented in this form. But also, we just don't need to say yes or no. We have to say the minimum number of times, minimum number of operations, or the minimum, we have to minimize the k so that our total number of, sorry, so that we reach the num of 1 as quickly as possible. So, the basic thing is that if we start iterating from k is equal to 0, k is equal to 1, and like, yeah, we try until uh, we try until uh, a certain lower bound is hit. So, or yeah, a certain lower bound is hit. Then we can say that okay, after the lower upper bound, sorry, after a certain upper bound is hit, we can say okay. So if we go further, if we iterate further down the k, then we can never reach our like desired result. That is, num1 cannot be 0. So we can just output -1. But yeah, if we reach our final answer, or like we our k satisfies our condition, this condition basically, then I can say, okay, you are the minimum answer is because we are going from k is equal to 1 to like we are like going on incrementally. And that's why I can like say if at any point I reach a certain condition, I reach I reach this condition, then I can say that my current k is my answer is because after the iteration we will reach to a k which will be greater than the current one. So yeah, this is my minimum. Now, how to do that? How to like check? So this condition. So for example, if my x is 13, so if I represent my 13 in terms of binary, it will be like 1, 0, sorry, 1, 1, 0, 1. Basically, it is 8 plus 4 plus 1. That is 13, right? So what I understand is that I require at least at minimum three, uh, my key has to be at least 3 to represent 13, right? Because we need at least 2 powers of 3 to represent 13. We need at least 3 powers of 2 to represent 13. Yeah. So basically, what I can say is that my lower bound of k is that k must be greater than equals to the number of bits of x. So what I can say, number of bits of x. So that is going to be my lower bound. Now we have to talk about the upper bound. So now the upper bound is simple. I think we already know the thing that my k will sorry, in one operation, my whatever least I can choose is 2 to the power 0, right? That is 1. So in one operation, I can subtract 1 at max. So yeah. So basically, if my k is greater than x, then it will be minus 1. Because if my k is greater than x, so if I go on subtracting, my answer will be definitely negative. And num1 minus this number operation will never reach 0. It will always be negative. So my k must be less than or equal to x. So what I get from here is that number of bits of x must be less than equals to my I think uh, k, and k must be less than or equal to x. So that's the final thing I got it. And using this thing, I can easily get to my answer. So yeah. So now if I start, so I initialize my k to be 1. Yeah, so I am starting the code now in C++. So yeah, my k is initialized to 1. Now what I think I can do is, like, I will initialize x. My current x will be num1 minus k times num2, as we discussed earlier. And now, while my lower bound is correct, so sorry, upper bound is correct, that is my k is less than equals to x. What I will do, I will do x equals to sorry. So I will check whether the this condition is also satisfied. That is my, if is my k greater than is equal to the number of bits of x. So for like counting the number of bits of x, there's a built-in library in C++ that is built-in pop count. So I will use it, built-in pop count, and as because it is for long, so we can be like using built-in pop count LL. And this thing is for built-in pop count LL of surely X here. So if this condition is satisfied, I will return K, because yeah, if I go further down, I will just increment my K, and if I go further down, we can never reach such a condition where my, basically we can not reach uh, a more minimum, or like a minimum a more minimum K. So this is going to be my answer. And now what I will do is, like, I will simply now update my x, or like I can just increment my k here and update my x to x equals to num1 minus k times num2. And yeah, and if I reach here, basically my while loop terminates. I know that it is not possible anyhow to represent the x in terms of powers of 2. So my answer will be minus of 1. So yeah, I think that's correct. I think we did it correctly. Yeah. So let's run it now. Yeah. So if I try to submit it, so it has got submitted, accepted. So yeah, that is the solution. It was a little bit like, yeah, more mathematical side. It was a quite a good question. I think you like the solution. So yeah, let's meet tomorrow for the next POTD. For then, goodbye from this end.